Okay, so yesterday we were talking about the OSI model, going through the different 7 layers of it. We'll go over that a little bit again today, but then we're going to be talking about TCP, UDP type connections and the differences between them. And I have said in the past in other videos that I've done that I would be not doing editing of the videos. I would just be showing what I was doing and things like that. Because I'm not showing a whole lot of this is very basic information for most folks in security. I will be actually editing this video. And some of that's also to make sure that I am getting the information as correct as possible, and also just to give it a little bit more of a concise feel. So I'll be pausing it periodically and you will be able to detect that. So let's go ahead and jump in and get started. So the first thing that we're going to talk about today are packets and frames. Now this is in TryHackMe, so they get the full credit for this. And there's also other pieces I'll be adding from different sources, which I'll include in the description below. So packet is basically a little piece of data that's going through a network. And this happens in the layer 3 area, which is here, the network layer. And that contains information, of course, the IP header, payload, etc. Frame is a little bit different. So frame is layer 2, which is the data layer. And that encapsulates the packet and then adds additional information like MAC addresses. So it starts here as a frame, then turns into a packet, and then that packet will get transported, and then you'll have your session, presentation, application layers, etc., that sort of thing. So that's how it's relevant for the OSI model and how it travels through things. And then it gives an example using an image and stuff like that. It includes other additional information, time to live, checksum, etc. So we will skip through some of that, although you should probably take a look at it if you're not familiar, and maybe do it through TryHackMe. But we'll take a look at TCP next and talk about that part. Okay, so the thing about TCP is there's a few differences between TCP and UDP. So UDP is what's called a stateless connection. That means it does not do what's called the three-way handshake, where it verifies things. It does not do that. TCP does do that, and you can see what's called the three-way handshake here. What that is there's 3 things that happen. For the person who's sending information, which would be Alice in this case, sending it to Bob, there would be a SYN connection that happens, or a SYN interaction that happens. I may not be getting the terminology totally correct here, so forgive me if that's the case. But essentially, that SYN would go out to Bob, then Bob would send an acknowledgement, which would be a SYN ACK, is what that's called, and then finally there would be an ACK sent that verifies that has all happened. The strength in doing this for TCP is essentially it ensures that critical information isn't lost as it's being transported. And let me just go here. All right, so it makes sure that that information isn't lost as it's being transported. That's the stateful connection. The stateless connection would be UDP. So TCP is really good for doing things like sending files, making sure that data has good integrity, stays cohesive, stays together. UDP is a little bit different, so it's that stateless connection, stateless protocol. It says it doesn't care if data is received or not, and that's true. So it's faster than TCP, but you also lose some of the data. So you might have experienced this when you're using a video connection, where you're on a video call with somebody and the person's like, well, that's because the UDP connection that's there is losing some of that data. But it's faster, and it's less intensive on your computer. So, and less continuous. It does not reserve a continuous connection, whereas TCP does do that. So TCP, you're getting all those packets, which are resulting in you being able to download that file and make sure that all the file is there. Whereas UDP, you're not really not getting that, and that's usually the audio or the video calls that you're doing. That's when the connection happens. And unlike TCP, there's no three-way handshake. There's no SYN, SYN-ACK, ACK. It's just request response. That's it. That's all there really is to that. So both TCP and UDP, and I believe, and especially TCP, different ports are used to by different programs to sort of send information, receive information, do things like that. And you'll see that here. There's two sources where you can actually look into all the different ports that are available. There's like over 65,000 different ports. But the first 1,000 or 1,024 are what are called common ports pretty much. You can find more information here at iana.org, which will be in the description. And there's like hundreds of pages here. Later on, they don't actually show the port number. They just talk about it. So if you go to like the final 146, the port number just isn't there for some reason. You can also find a really good, and this is the one I usually refer to myself, is the Wikipedia page on the list of TCP and UDP port numbers. You can see the scroll bar. It starts at port 0, which is reserved, which means you can't use it, I don't think. I think that's what that means. Maybe I might be wrong about that. But there's all these different ports that are here, and you can scroll all the way down and look and see that there's like tens and tens of thousands of these. And this doesn't even include everything, because this goes to 64,738, but it's over 65,000 ports. So even here it doesn't include everything. You might be able to look this up somewhere else or talk to your LLM and figure that out for the ports that are missing. There's a few common ports that are really good to kind of be aware of. One of those is port 80, if you can get over there. So that's this one here. That's where the internet essentially happens, HTTP, excuse me. So this one is really critical for that and used for that. It's by default. You can reset the port manually for where things go for applications like Firefox or Google, but usually it would be port 80. Sometimes if two programs are trying to use the same port, that can cause a problem. So you might be using a port successfully, and then you download a program that wants to use the same port, and then there's issues there. And then you can't just use any port for anything that you want. Like some ports are a little bit more flexible than others, but some of them are like very specific for very specific things, and you can't always, if you try to force it, it's not going to work. At least that's my understanding of this. So that's something to keep in mind there as well. And let's see if there's anything interesting to talk about. There's more than just port 80 for the common ports. But you can see there's some like really random things in there. Like I don't know what a Gopher protocol is, for example. There's also ports for printing. Let's see if we can find that. Printing protocol. So 92 would be for the network printing protocol. And line printer, that's line printer. Let's see here. Different things like that. So these are things to know about. Like you're not going to memorize the ports, obviously, 65,000 ports. Like who would do that? Maybe somebody has some really weird person that's, neurodivergent, but I'm not neurodivergent enough to do something like that. So that's pretty much it for this. And that's pretty much it for a very, very, very quick rundown, very basic, not in-depth rundown of TCP, UDP, the strengths, the disadvantages between them, the fact that there are ports out there, what those ports are, some places you can go to find out more about that information. And then also, I would say, this information comes out really handy in places like this where you're starting to, like Web Security Academy, which is Port Swigger. There's a lot of good exercises where you will start using this information. This information is also helpful in a cloud-based context as well, which I talked about a little bit in the last video. So in some aspects of networking where you actually start using CIDR ranges and split things into CIDR ranges, and you have different classes of networks, that becomes important because you usually within cloud platforms have a certain allocation of CIDR ranges that you can use. And once you fully use a certain range for certain things, you have to be careful with how you do that, because you could exhaust the addresses and then you have problems with being able to have the infrastructure support that you need for your applications. So it gets kind of complicated, and that gets into the realm of cloud engineering. But all that stuff touches on security, because this is all about different devices and different things, different programs talking to each other. And if you can do a man-in-the-middle attack, you can just do other things, then it's possible to exploit that and cause a lot of problems, obviously. And of course, on the defensive side, you have to be right. 100% of the time. As an attacker, you just have to be right once. It's very easy. But for the defensive side, you have to always be watching, always be prepared, always be ready to respond, and always be trying to think of all the things that could happen and defend against all of them, all the time. So the defensive side is a lot harder. A lot of people who get into cybersecurity, they think about cybersecurity as hacking and penetration testing, and that's just not really the complete way that works. But anyway, that's enough for today. Talk soon. Bye.